Hi everybody. I want to go through the math one more time for you for fractional crystallization, and you can use this tutorial to help you take the quiz that I know you're going to be taking in class today. So let's think about this. What we want to know mostly on the quiz is what's in our filtrate and what's in our filtride. So I just want to remind you what we're talking about when we say filtrate and filtride. And if you don't remember the definitions or which one's which, you have them in the notes packet that I gave you in the vocabulary list. But here's a quick reminder. When you filter, you will have a funnel, some filter paper, and a container that you're filtering into. Anything that gets stuck in here in the filter paper is called a filtride. Anything that goes through, any liquid that goes through, and anything that's dissolved in that liquid is called your filtrate. So what these sheets are really asking you is what's in your filtride and what's in your filtrate each of the 2 times that you do a filtration. And when you fractionally crystallize, you filter twice. One time you're going to filter at 70 degrees, and the next time you're going to filter at 20 degrees. So what you have to do is figure out how much stuff is able to dissolve at those 2 temperatures, because whatever's dissolved will be in your filtrate, and whatever's not dissolved will be in your filtride. So let's keep that in mind as we go through this exercise. So first, let's look at our salt. At 70 degrees, how much salt can dissolve according to the graph? Well, it's hard to read the graph for the salt because the salt line doesn't really go up very sharply. But if you look carefully, you can figure out that you're going to be almost, but not quite. Whoops, see, it's hard to do this with the iPad. Almost, but not quite at the 40 gram mark, right? This is going up by 20s. This is 20, 40, 60, 80, 100. So I'm going to say 39 grams or so, maybe 38 grams of salt can dissolve. But that's out of how much water? So this is my 38 grams of salt, which the chemical symbol is NaCl, can dissolve in how much water? Well, if you look at the units over here on the y-axis, it says 100 grams of water. This is telling me how many grams of my solutes can dissolve in 100 grams of water. Now, previously, on our previous graph, and the one in your book, it says 100 centimeters cubed of water. Well, it turns out that for water, the density is 1. All water at room temperature has roughly a density of 1.00 grams per milliliter, which means that for every gram of water you have 1 milliliter of water. Because obviously the only way you can get your density of 1 is if your mass and volume are the same. That way you're dividing the top number by the same number on the bottom, and that turns out to be 1. So you'll often see units on solubility graphs that say 100 grams of water. Sometimes it'll say 100 centimeters cubed, sometimes it'll say 100 milliliters. It's all the same thing, but only if you're talking about water, because water has that density of 1. If we were using a different solvent to dissolve stuff in, then we couldn't use grams as the units here because it wouldn't work. So we have 38 grams of salt in 100, I'm going to call it milliliters because that's more comfortable for us, in 100 milliliters of water. But in our fractional distillation, we're not using 100 milliliters of water, we're only using 10 milliliters. So we have to set up a proportion to figure out how much are we going to get to dissolve in 10 milliliters. And we've talked about this. You cross multiply to solve for x. So if you do out all the math, you're going to get 380 equals 100x, and then you divide both sides by 100. Because I'm kind of short on room, I'm not going to show that work, but it's just, when you cross multiply, I multiply these 2 things times each other, and then set that equal to these 2 things. And then I'll divide to get my x alone. That's going to give me, and we've done this a bunch of times, that's why I'm not really doing it again, 3.8 grams. That's how much salt can dissolve at 70 degrees. So what that means is, if you go over here and look at how much of each substance we started with, here's my salt on the bottom in blue. How many of those x's are going to dissolve? Well, almost, but not quite 4 of them, right? This one will dissolve, this one will dissolve, this one will dissolve, and most, but not all, of this one will dissolve. And then what's going to be not dissolved is going to be that little piece of X that you see hanging out on the right there, and the 4 X's on the bottom, which, since we have 8 grams of salt to start with, 8 X's, that means we must have 4.2 grams of salt that don't dissolve. So, what's going to be in your filtrate and what's going to be in your filtride at 70 degrees? For the salt, in the filtrate, the dissolved salt is 3.8 grams. For the filtride, it's going to be the leftover salt that didn't dissolve. That's 4.2 grams of salt. It's getting really crowded in the sheet, but hopefully you can follow that. All I did is figure out how much of this stuff will dissolve, and we said that 3.8 grams would, so that 3.8 grams will go through with the little drops of water, and the remaining 4.2 grams will get stuck in the filter paper. What about the KNO3? Well, we got to go up at 70 degrees and see how much KNO3 or potassium nitrate dissolves. And if you do that, you'll find that it's roughly 138 grams that will dissolve of KNO3 in 100 milliliters of water. Same thing, we're going to cross multiply, and when we do that, you'll find that 13.8 grams can dissolve in the 10 milliliters that we have. But if you look, we don't have 13.8 grams, we've only got 5 of our KNO3. So all 5 of our KNO3 grams are going to dissolve. So they're all going to be down here in the filtrate. These two things are going to go in the filtrate at 70 degrees. None of the KNO3 gets caught in the filter. And that's a good thing, because the whole reason we're doing this is to separate them from each other. So at this point, we've gotten out some of our salt, right? We've got 4.2 grams of our salt in our filter paper, good for us. We want to get some more separation. So the next step is going to be to filter again at 20 degrees. So I'm going to clean this up so we get a clean screen and see if we can figure out what's going on there. Okay, so I cleared the screen, and we want to figure out again, filtrate and filtride. What's going to be caught in the filter paper? What's going to be caught going through with the water? So at 20 degrees, the two things are much closer together. The salt is just a little bit less soluble at 20 degrees. So I would say we're going to get maybe 37 grams to dissolve. And again, that's out of 100 milliliters of water. And if we set that equal to X over 10 milliliters, we'll figure out that we get 3.7 grams of salt to dissolve. Now, you might remember that we filtered out 4.2 grams, right? That was filtered out in the previous problem. So I'm just going to get rid of those X's. I'm just going to scribble them out. 1, 2, 3, 4.2. All of those guys were already removed in the previous filtration. So what do we have in our water? Well, we have the remaining 3.8 grams of salt sitting there, right? This is 3 guys, and this is the 0.8. And we can, but only 3.7 can stay dissolved. That's what we just figured out. So 3.8 minus 3.7 is 0.1. So that means that 0.1 of these X's is going to get stuck falling out, right? We're going to be able to dissolve basically almost all of this stuff, and a tiny little piece of our X is going to get stuck in our filtride. So we're going to get 0.1 grams of NaCl in here, like a little tiny piece of an X. And what about the potassium nitrate? Well, at 20 degrees, not so much potassium nitrate gets dissolved. Only 32 grams out of 100. So if we do 32 grams out of 100 milliliters equals X out of 10. Cross multiply, you're going to get 3.2 grams of KNO3 can stay dissolved. So my KNO3, we had all 5 of those were dissolved, right? So they're sitting there in the test tube. But as the test tube cools down to 20 degrees, 3.2 grams will stay dissolved. So the 3 on the top, this one, and this one. And 0.2 of this guy will all stay dissolved. So that means this little bit of stuff here is going to fall to the bottom and it'll get stuck in the filtride. How much is that? Well, 3.2 subtracted from 5 is 1.8, right? Isn't that one circle and 0.8 of a circle? So 1.8 grams of KNO3 will be in our filter paper. Down here, what's in our filtrate? Well, in our filtrate, we have the remaining stuff, right? We've got our 3.7 grams of NaCl, that's our salt, and our 3.8, no, not 3.8, 3.2, right? Hold on. There we go, 3.2 grams of KNO3. And that's all going to be in our filtrate. Now, you can see that we didn't manage to separate this much of our solution, right? That stuff's going to stay mixed together, and we would have to do a lot of stuff to get them apart. But we did successfully get, in the first filtration, you'll remember we had 4.2 grams of salt, and in the second filtration, we've got 1.8 grams of KNO3. So it's pretty good, you know, and this KNO3 is slightly contaminated with about 1/10 of a gram of salt. So hopefully that helped you understand the math a little better so that you can do the quiz. The quiz is the same exact process, just using different substances, different numbers, and a different table, the different graph. The graph that you're going to use for the quiz is on page 74 of the Brown Book. And you can refer to any notes you've got. You can refer to this tutorial. You can go crazy trying to figure it out. And that's what I want you to do. You can take the whole period to do it. And if you finish up early, you should be reading chapter 15. And I'll see you guys in class.